All right, this is our second video for 11.6. My apologies that the examples are missing for 3 through 6, but I have those in here now. So we're going to skip through where we already were, and we're on problem 3. Okay, so we're taking a look. Same directions, of course, is that we're describing and sketching a surface. And on this one, on number 3, we have it actually already in the form that's most helpful for us to see. It's x squared plus y squared over 4 minus z squared over 1. They all are squared, and you'll notice that one of them is negative. And if we compare that to the different options that we have, that makes this a hyperbola. Hyperboloid is what I meant to say, I'm sorry, of one sheet. Okay. And in terms of a graph, it kind of looks a little bit like you draw a cylinder, except you draw a cylinder in such a way that it has curvature on the sides. So you have this sort of a shape going on, right? And it looks like this. And of course it's opening in this case along the z-axis because that's the negative axis here. And then we have these sort of cylindrical sort of shapes at the top and the bottom. And just to kind of clean it up, I'll shorten it off there. So this is a hyperboloid of one sheet. And then we have this one, y equals x squared plus z squared. On this one, you'll notice that one of the values is not squared, right? And so if you take a look back, one of the ones that we have that's showing up like this is actually, where I've got the positives here, is an elliptic paraboloid. So this is an elliptic paraboloid. All right, get it spelled right there. So what does an elliptic paraboloid look like? Well, it looks kind of like a bowl, and on this one it's going to be easiest if we can continue to draw it in the way that it's sort of shaped. But if you notice that the actual, well, I'll draw it actually with it the way that we normally have. So here's z, here's x, and here's y, and you'll notice that the axis that we're extending around or drawing around is actually the y-axis. So it needs to be a bowl, in this case opening to the right. So it kind of looks like this sideways bowl like this, right? And if you imagine that there's a bowl here, right, like this, maybe it would be easier without those. So here is my sort of bowl shape. They're ellipses, right, that are opening on the y-axis. Next one, number 5. Not exactly in the shape that we normally see this equation. I've got a square root in it, right? So we can eliminate those square roots. We'll square both sides. And these are all squared, and all of our equations where they're all squared have all the values on the same side. So I'm going to move, I'll just move the z over here to the right hand side. So I have 0 equals, I have x squared plus 4y squared minus z squared. And then again, I usually have coefficients that are all 1, and I potentially have denominators, so I'll divide everything by 4. So in each of these examples that you do, you're going to put them into what we would consider sort of the standard form for these. So x squared over 4. I end up with plus y squared, and then minus z squared over 4. So very nicely done, and we're going to identify what kind of a shape that we have here. And again, looking back at my options, this one is an elliptic cone. So it kind of looks like, you know, an ice cream cone on top of another ice cream cone. The axis is the y-axis, or is the z-axis, excuse me, because that is the sign that is negative. So we're going to have a shape that looks like, whoops, let me use something straight to draw that, that'll be easier. That looks like a cone opening upwards and a cone opening downwards, right? And it has, you know, this elliptic shape on the top and the bottom. Let me see if I can copy that and paste it. Nice. Okay, so here's my elliptic cone. And then I believe we had one more, problem number 6. Again, probably one of the more difficult ones to draw. This one, not in standard form yet, but I can divide by all of the pieces by 4. I also noticed that I have z by itself, as in it's not squared, so we actually need to get it solved for z too. So we're going to leave the z on this side where it is, and we'll move the other pieces. So now I have 4y squared minus x squared, and I don't normally have the 4. Now this one looks a little trickier to get rid of the 4, because the equation, if I divide everything by 4, would then have a 4 underneath the z, and that's not how it's written either. So what we're going to do is something a little different on this one. We're actually going to rewrite the multiplication by 4 as division by 1/4. Right? Dividing by 1/4 is the same as multiplying by 4. So this would actually be the standard form of this equation. And comparing back, this is a hyperbolic paraboloid. It's the saddle. The z-axis is our centered axis. So the z-axis will be drawn, let me change my color, where the parabolas are actually opening around it in both directions. So we have one parabola that looks like this, the other parabola that looks like this sort of a shape, and we're having this one here. It's not very good, but you know, you can pretend with me for a moment. We'll see if I can make it look a little bit nicer by deleting this piece out. That's not too bad. So we actually have this sort of a saddle looking shape. It might be easier to sort of draw in some of the curves of the saddle, I don't know, and then we can see them on the back side like this, right? So here's our hyperbolic paraboloid. And again, I already showed it this, but just in case not, these are the examples, not the examples, this should say homework, that's a typo. Please know that this is not this is your homework assignment on the last slide.